Good afternoon, everybody. Once again, delegates as well as my fellow panelists. We have an interesting session right now. Uh, uh, just after, say, lunch, um, this is a topic on R&D. As Professor Kandal always say, that is not the priority. Why is it not the first session? But somehow regulatory compliances come into picture beforehand. But anyway, this is not the last session, so it is in between. So I think you will excuse me for that. And the topic is new sustainable materials for chemicals and petrochemicals industry. That is what the industry is moving towards. And what are we going to discuss? We are going to discuss on development of new sustainable materials in chemicals and petrochemicals, integrating capabilities to drive long-term value, digital approach to solve material challenges, creating synergy between industry and academia, enhancing Indian inventorship of patents, and mentoring startups of green chemistry. Why we have chosen this topic and why we have added sustainability? Because we thought that because that was our main theme, sustainability, and we looked at new materials because that opens up a new opportunity for all of us, not only in India, but outside India. And with such eminent panelists among within in this panel, I think they will add a lot of value. Let me introduce you to our speakers. We have Professor G.D. Yadav. I think anybody who is in the chemical industry will know him. He's the Emeritus Professor of Eminence, Institute of Chemical Technology, Bombay. Mr. S. Shriram, Chief General Manager, R&D, HP Green R&D Center. So we will hear to know more about what the Green R&D Center is doing. Professor Dr. R.K. Khandal, he in a very simple terms, he tries to explain things which have a very deep meaning for India. And he also talks about the opportunities which it brings. And he's working on very different materials. Recently, the R&D Center, what we can say, he would be formally inaugurating, or you just have done the bricklaying work to
this
start?
Was foundation stone.
The foundation stone has been laid, and the building is coming up. So you will
will be commissioned in 2 months' time.
Okay, so this year the building will be commissioned. Bijal Matkar, Research and Innovation Director, Solvay Research and Innovation Center. A lot of international R&D is also done at her center. And she is also looking at expanding her R&D facility. Art Subramaniam, Deputy General Manager, Quality Assurance Head, Bharat Petroleum Corporation. So we have a mix of both oil, petrochemical, chemical, and oil and gas. So which is very important mix that we have. Dr. Heathen Mehta, he's the head of R&D Chloralkali Aditya Birla Chemicals. So with your permission, I take the liberty of starting this session. And let me start with the senior most person, and then I will move to Bijal, the only lady in the panel. Professor G.D. Yadav, sir, you have been associated with a lot of industries, and you are also associated with ICT Bombay. So yeah. Where is the missing link, and how do we move to this new sustainable materials which are coming up, whether in terms of EV, or whether in terms of solar panel, or whether in terms of say sustainable materials that consumer is asking for? So how do we bridge the gap and take a lead? Over to Dr. Professor G.D. Yadav.
It's a very good question. One of the missing things in Indian academia and the industry per se is that the industry thinks that the academia cannot solve their problem. That is a very big issue. But it is not true. And the other reason is that, I think most of the time the industry wants to import technology, ready-made technology. In fact, that happens with the best of the industrialists. They have R&D because they can show that expense against R&D, but really speaking, they are not taking it to the next level. And who helps it? For example, in China, the academia is very much involved in developing technology. The academia is helped by the industry, and all these processes, patents, etc. You will see that they are coming from academia. In India, what is happening, barring a few institutions like ICT, for instance, because I have been involved with that, others do not go to the academia to solve their problems, particularly problems related to scale up. So what you are mentioning about the new materials which are required, remember, we will not have any crude oil by the year 2050. So what are we going to do? That means we have to go to biomass. And the biomass conversion can happen only through hydrogenation and oxidation. So hydrogen and oxygen will come from water. So water splitting, green hydrogen and all, these are going to be very, very important processes. This is number one. And biomass of any kind, including waste plastic, can be converted into new chemicals and materials, oligomers, polymers, whatever. Remember, if we do not have, and I always call this the new term which we should be using is recycle engineering. We have to recycle everything, in one form or the other. So chemical reactions are going to help us. It is some processes could be physical, some could be biological, and most of them will be chemical. So chemical engineering is going to come to the fore. So whatever we were doing all these days, we will have to go to this. For example, we are talking about the net zero by 2050. That is, the carbon dioxide concentrations have to come down and the global temperature should not rise above 1.5 degrees C. That means we require carbon dioxide refineries, and carbon dioxide refineries are possible only through hydrogen. So hydrogen, so I always call this new trinity, like Brahma, Vishnu, Mahesh. Our new trinity will be solar, wind, and hydrogen. And hydrogen assumes the most important position in this because the other two can give you energy, but they will not give you materials, whether renewable materials or whatever. So hydrogen is going to be a very big important factor in all these things. And coming back to the academia, a lot of work is being done. A lot of work is being done in IITs and ICT and other central universities. But what is missing is the academics are not interested in making it commercial. See, they will publish papers in best of the journals and they will leave it that way. So that is not good for the country. We must develop our own technology. We are not going to get technology from abroad. So remember that. So technology has to be developed. Design procedures have to be developed, and that has to be done by academic institutions. And industry must, generously support this academia. In fact, I had suggested this to Niti Aayog and one of the central ministers very recently, that the CSR contribution should be raised from 2% to 3%, and the extra 1% should be given to higher education. All the best of these institutions in the country where they can develop technology. This is the need of the hour because government is not spending enough money on higher education. We are talking about 6% of the GDP will be spent, but nothing, nowhere we are there. And we are comparing ourselves with America and Europe and whatnot. So my personal belief is that hydrogen will play a very important role. Biomass conversion into various chemicals and materials will be very, very important. So whether you are talking about green hydrogen, green ammonia, and all those things, very important thing is that to develop new. So we'll have new platform chemicals. Benzene, toluene, xylene refineries, yes, good. But our new platform chemicals will be, for example, we have, say, hydroxymethyl furfural, HMF. And from HMF, we can make many, many other things. Okay, it is not that only HMF will help us. Okay, like xylose as a platform molecule. We can go to a variety of different, very high valued chemicals. Lignin as a raw material. So we will have a lot of resources to be converted. And this is where, the other important part as far as chemical industry is concerned is that this downstream chemical industry. Okay, many of these global oil and gas majors are turning their attention to the downstream chemical opportunities. And this may increase the focus on petrochemicals in India, and the higher investment will happen in the particular sector. That is what I believe. Okay, so And I can come back to this after some time. But yes, industry-wise, there has to be some prioritization of core businesses and consolidation. Okay, so there will be also mergers and acquisition that is going to happen. So what role academia can play in this? Academia can play in developing new processes, new technology. Separation processes will be very, very important. And you were mentioning about AI and digital technology, right? So many companies across the world are enhancing the digital potential. And Indian companies should also tap into this opportunity to expand their in profitability. And lastly, sustainability is becoming an imperative. And it is just not a buzzword. And all stakeholders have a role to play in it. And chemical companies will prioritize environmental sustainability to protect the long-term shareholder value, whereas they will also comply with the regulations of the local government. So I will talk a little later about the alternative feedstocks and what can be done. Thank you very much.
Thank you, sir, for your initial remarks. Now I move to the oil and gas sector and ask Mr. S. Sriram, Chief General Manager, R&D, HP Green R&D Center. Sir, what is it that you are developing in your Green R&D Center, which would be sustainable and would solve the purpose for future? So over to Mr. S. Sriram.
Yeah, good afternoon and namaskar. Hope I'm audible.
Yeah, you are audible. Please go ahead, sir.
Yes, sir. Okay. So first of all, thank you for this opportunity, Praveen. So it is my honor to be one of the panelists along with the elite group over here, and wish to mention that we have invited Professor G.D. Yadav for our one of the session over here. So we'll be very happy to welcome you, sir.
Thank you.
Yeah. So thing is, our R&D is relatively a very young R&D if you compare to our IOC or anybody else. It's a relatively new R&D which we have commenced our operation from 2016 onwards. But from 2016 to now, we have come a very long way. To be in fact, our R&D, we do have as of now around 16 labs, which we have installed in phase 1 as well as phase 2. And as a future, what we are looking up is on the energy transition mode to have more focus, as Professor has told, on hydrogen. And we are putting an emphasis on water too as a research lab, because in water also in future can be a scarce resource. And we are putting our foot on the solar. So these are the prime segments that which we want to take it up. And another segment what we are looking at is on the Global Technology Development Center, which we want whatever our process units are there at both our refineries as well as our JVs. We want to have a kind of process and troubleshooting support of a high level from our R&D center. This is what basically we are looking for as a futuristic. Now coming to the aspect of what the Green R&D Center is doing. Recently, we have started a Petchem lab, which was just hardly 3 or 4 months old. So we are into a lab scale process of looking into polycarbonates, which we want to make it from biopolymers. So that is on a lab scale that which we are looking into it, so that whatever the polycarbonates which we can make from phosgene and bisphenol, we want to avoid, which are carcinogenic. Having said this, we have advented or we have moved into our own technologies of in a pilot as well as demo scale, that which we have put up within our facility on 2G ethanol. So we are exploring various ways, because in the 2G ethanol, the enzymes are the more costly ones, which we have to look into it. So we are looking into how we can do various kinds of enzymes, which we can make the conversions a better process. And in the process, we are looking into the aspect of lignin, how best we can utilize that lignin. So we are seeing whether it can be utilized in a better way as a chemical, as well as whether any feasibility exists so that it can be blended with asphalt to make a bio bitumen. So that is also one of the aspects that which we are looking at present. And to tell upon as to follow the green hydrogen, that rather the hydrogen mission which the government has mooted already. Our Vizag refinery, we are setting up a 370 tons per annum of a pilot project of green hydrogen. Already it is being under implementation, and we expect it to go online by December 2022. It is being done by Technip, and we are having an alkaline electrolyzer, which is given by Eastern Electrolyzer, which is an Indian, this one. So as a way forward, we are looking at an aspect of setting up 85 megawatt of two numbers of water electrolyzers to comply with the green hydrogen compliance requirements by 2030. So the first phase will come by 2025, and the second is expected by 2030. We are in dialogue with various people to understand or have an idea whether we should go in BOO basis or how we should go about it. So from the refinery perspective, we are there on the track looking for a green hydrogen in the prime focus, and subsequently we are looking for the chemicals which is more eco-friendly and which can be sustainable, which can be offered to the public as well as the market. And as Professor has told, there is more focus has to be there on go-to-market. That is rather the commercialization. So the way in which that we are going to take up from pilot to demo as well as the commercialization has to be driven systematic, and it has to have its own impetus so that we can take it in the right manner and at appropriate time so that we can be self-reliant to meet the Atmanirbhar. Thank you.
Thank you, sir. Now I come to Professor Dr. R.P. Khanda, President R&D Business Development, India Glycols. And sir, do you agree with Professor G.D. Yadav, and he talked about hydrogen and biomass, or do you feel there are other substances from which sustainable materials can come? So over your views, sir.
Pranam, Prashantji. First of all, I must compliment ICN for bringing people from different spheres of science and technology together on one platform. I think it's a great opportunity. Only when we discuss about our issues, we learn about each other. Before I answer your question, I just want to tell you that in India, we have a lot of established and existing experiences that we are supposed to multiply. One of the experience and expertise is that of India Glycols. Is the only company first in the world, of course, then first in India, to manufacture everything renewable. Imagine when all over the world, Brazil is #1 in manufacturing ethanol. India Glycols is the one which went ahead. Not only ethylene, but ethylene oxide, and then all sorts of renewable surfactants. This is one aspect of sustainability. And here we talk about sustainability to self-sustainability. Sustainability is time dependent. Self-sustainability is forever. Now, when we say self-sustainability, the main raw materials that come, the source material, the base material that come into focus is the biomass, which Professor Yadav has said. Professor Yadav has, what he has said, I completely agree with him. We have to take out chemicals from biomasses. Biomasses of various types, and not to have conflict with the food, because food versus fuel or food versus chemical competition will not be making it sustainable. In our last budget, Prashantji, Government of India has already made 2 announcements, and they are very, very important announcements. Please mute yourself. There's somebody who is. There is one announcement which is related to green hydrogen. Government of India has said that we will focus green hydrogen for manufacturing urea and green hydrogen for all other processes where hydrogen is required, for example, hydrogenation reactions. The second announcement they have made is about the biomass. They have said that in the boilers, in the thermal power plants, we will replace the coal by biomass. These two developments will lead to several issues which will help transform chemical industry in India, because biomass is going to become a big resource for all of us. The second point Professor Jadhav has said is about CO2. Please understand that all the CO2 that we have emitted or we have been emitting, unless we capture it, we will not be able to make the world sustainable. The humanity will not be sustainable. If we are able to capture it, the only plant which is doing capturing CO2, converting that into ethanol is in China with LanzaTech technology. But we have to do this in India. We have hundreds of distilleries where this possibility is there. We produce so much of bagasse, we burn parali, all that has to stop. So fine, we are replacing coal by biomass, but we are also supposed to do converting that into ethanol. Now the question comes, why we are not successful in that? Please understand, till the other day, we were not able to mix more than 5% of ethanol in fuel. Today we have reached 10 and we are talking of 20. Why we are able to do it? Because the government has given incentives to those who are producing ethanol from bio route. For example, molasses, for example, now grain. So many distilleries have come in last 2 to 3 years in operation where they are producing ethanol from grains. Government has to take a decision that they will give more incentive if you go for a technology which produces ethanol from biomass. And there is a technology, Clarion technology is one, which in my opinion is the best because they have put up a plant in Czechoslovakia. All our distilleries in India should be able to replicate it. Government of India has to take lead in getting that technology in India. Second point is about the gap between industry and academia. There are gaps everywhere in the country which we are supposed to bridge. The first gap is between university and research institutes. University does not have any link with the research institutes. Those who are teaching don't do research. Those who are doing research, they don't teach. Those who are developing technology, they don't do research, they don't do education. We have to bridge them together. The biggest hurdle in the growth is the fact that we have 37 CSIR laboratories, and CSIR is Council of Scientific and Industrial Research, but 80 to 85% of their work is only scientific. It has to be industrial. Imagine, Prashantji, if we give the mandate to all the CSIR labs to associate themselves with the industry and do research for bringing out technologies, we will be number one in the world. At the moment, you know what is the process of doing research? Just now I was reading the statement of the minister. He says by 2024, we will reduce our dependence on China for the key starting materials by 24%. We should have the target of 100%. That will be possible only if we transform our system of funding the research. How we are doing it at the moment? We ask the scientists to give idea. He gives the idea, then we fund the project, and no connection with industry. He or she works for 10 years, 15 years. Then we say, bring the industry link. We should start doing the industry link from the beginning itself. Attach the CSIR labs and government funded labs with the industry. And please understand, we will not be able to grow if we depend for our key starting materials on China and on imports. Imagine one drug out of 4 in US is produced in India. 1 drug out of 6 in the world is produced in India. We are the largest producer of generics, but 80% of our key starting materials and APIs are coming from outside. I would just say before I end this session, just now it was mentioned about polycarbonates. You know, we have CO2, we have ethanol, we have green ethylene, we have everything green existing with us at plant scale. We need to really group together and make molecules out of it. 150 years ago, first time we started making chemicals from coal. Then came petroleum, then came gas, then came natural gas. And now it's the time for biogas. So I end my speech saying at 3 levels, we have to bridge the gap between academics and research and technology, bridge the gap between R&D funded by Government of India to make it industry related. All research done in industrial in the government funded labs should be industry related, and there should be both ways interaction. Industry should adopt them and they should adopt the industry. Thank you very much.
Thank you, Professor Dr. R.K. Khandal. And I think similar views are also echoed by Bijal Matkar, Research and Innovation Director, Solvay Research and Innovation Center, India. And my question to her would be, how do we integrate the capabilities that are in and around us and drive long-term value? So over to Bijal Matkar.
Yeah, thank you, Praveenji, and namaste to all my fellow panelists. It's an honor to be speaking in your presence, and hello to the audience listening live to us. Praveenji, you used a very good word, that's integration. And if you translate a mathematical integration, it is always 0 to infinity. So what I want to say by this, the symbol of integration is that we may feel that we have a lot of problems ahead, or we don't know, 100%, we have just scratched the surface, we don't know. So we may be at a 0 or a less mature stage at the moment. And only by this integration that we have infinite opportunities. So the new way of doing business, sustainability, as Yadavji had said, is not a buzzword anymore. I think it's the way that one has to do business in order to survive for the next 50, 100, 150 years, for the humanity and for the business, chemical business itself. So let me give a very nice example. When we were just listening and Rakeshji said that he's coming up with a new R&D center. HP also has a nascent R&D center. My R&D center is 10 years old. This is the 4th or the 5th R&D center which I'm hearing about in the last 1.5 months that various organizations across India are coming up with. So this is the first part of integration, thinking that what is required or what is needed for the future, we don't have sufficient. So, we need to come together. And I remember in one of our conferences, we said that if R&D grows and glows, we will have a better say in the market, or we will have a better say with the government, we will have a better say at policy level, and we will be able to accelerate, the challenges that we are facing just on the R&D side in India. And I think everybody's echoing that. The second aspect of integration, I would say, is if we believe what major firms or UN or United Nations Development Goals are saying, it's $1 trillion industry. Sustainability aspects, the way you challenge the status quo and do new things is going to be $1 trillion, because that's the way the whole world is going. Whether it is biosourcing or biodegradability or recycling, it's in that direction. So I believe that there is a lot. The pie is big enough. There is a good chunk for everybody. And I think in order to prevent reinventing the wheel and doing similar thing again and again and just kind of losing time more than resources, because I think we have a race against time here. It is now the chance for the industry, whether it is from the R&D segment or from the processing segment or the manufacturing segment, to come together and make sure that our goal or our purpose is sustainable humanity and not just profits. I think the days of profits are important, but it is profitable business plus sustainable business. This is what we have to look into. And the third thing on integration that is more on the molecular level is related to, we talk about reusing or recycling. I think we have gone from just that to circular economy, as we call it, right? So you don't only take ownership of cradle to grave, but you take ownership from cradle to cradle. So bring back what you have put into the system and then reuse it in a way. And that's where the real integration is going to happen, because you go to raw materials, you go to your supply chain, you go to the end user. The end user gives it back to you reform it, and then it kind of keeps on moving. And we as Indians, we have been taught the aspect of sustainability or recyclability or circular economy from very beginning. So it is just a matter of expanding it to the level where everybody buys in, sits on the table and says, yeah, we have a common purpose, and let's make our processes, products novel, and so, or go in the direction of novelty, or make the existing one sustainable. So that's my views. Thank you so much.
Thank you, Bijal. Now I come to Dr. Heathen Mehta, Head R&D Chloralkali, Aditya Birla Chemicals. And Aditya Birla is focusing on sustainable materials in all their divisions. So let me understand from him what are the new things that Aditya Birla is focusing on.
Yeah, thanks. Thank you, Praveen. Good evening, and thanks for giving the opportunity to speak on behalf of Aditya Birla and in a very interesting forum. So in Aditya Birla, basically, I am representing the portion of the business which is chloralkali, which is a part of our chemical business. But then sustainability is something that we are looking at almost at all the businesses, whether it is Hindalco or in our say cement industry, like or if we are going to the copper, or we are working for the chloralkali. So in this, basically your focus is to use and reuse the material what is being available in the environment. And in chloralkali, we start with a very straight raw material which is abundant in nature, is a sodium chloride, and then we forward integrate into the lot many things. And I echo what Bijal has stated, that in this particular thing, like in my previous experience where I was working with a pharma, overall integration is very, very important. So if we try to find the root cause, like why most of the industry is going to China for the raw material, like as Khandal Sara was stating. So in this particular, the answer would be that they are making this raw materials in a bulk, and then they can be a very cost competitive. But I have never heard this in my initial days, that where all the pharma companies will come together and will start looking at that, hey, we are looking for the similar molecules to produce, and we are one of the biggest generic industry, then we'll be needing this basic raw materials. Let us put together this need and go to the academics as well as to some investors and come up with that particular setup where they will be able to make this material and we will take this forward. So this is a need of integration, not only at one particular level or having the integration with the academic, but if you see overall as a business also, this is becoming a need of the hour, where practically we have to think that, okay, it is not like just having a portion of the business and copying what others are doing, but going forward as a country, like what China has done, that if the technology is available, you have to share and you will have to support so that your products will become more competitive to the world, not internally to the country. So this is where I think it's a very, very important point where the academics comes into the picture. But here again, there is this notion where you go to the industry or vice versa. What happens is the practical issues are not being taken in terms of a time frames. So they keep on doing lots of efforts, but at the end of the day, it may not become commercial tenure. So that slows down the overall industrial interest. Like coming back to what Khandelwalji has, Khandalji has raised, that government of India has initiated this a few years ago, that they have reduced the funding by the CSIR and forced industry to go to force these institutes to go to the industry for getting the projects so that they can fund their activities, and then finally they can run their academic institutes and the setup. But still the traction has not happened to the way or to the level what it was expected. Has started moving, results are evident, but then currently it is more about like a mere like a one portion of the total issue, not as a complete technology. So this is the thing where if we can come up with that, okay, this is a technology on which as an institute we are working. Say for example, a very basic chemistry, like converting the sodium chloride to sodium hydroxide, which is like what we teach in a very basic level of the schooling. But what can be the next level of this technology? What we can really make this more viable? How we can convert it into the more percentages in terms of the throughputs and reduce the waste? And what we can do with the waste so that overall it will become more sustainable. So that whole cycle, if we are supporting each other, not being just being competitive with each other or competing with each other, but thinking that, okay, we'll take it up to this level, and then there are industries who will take it to the next level. So this overall integration and understanding between the institutes, academia, and within the organization, again, you see there is lots of capabilities still in, as Rakesh was indicating, that India Glycol and Clariant are working together. But if you see that within the Clariant or within the India Glycol also, there are lots of talents. And again, our way of working is that we normally think for the vertical growth. So if the people who will just grow in the top of the ladder will be seen as the leaders, but then you have the lots of talent, those who are very much expert in the topic may not become a strong leader material, but then creating a support, creating that integration, that look, being an expert you can grow, go and support our various plants, various processes, and give the value addition, so that like in terms of the economical growth, you are at par with your CEO.
Hitaji, we are unable to hear you.
I don't know whether we lost him.
Supporting each other is something I think is overall integration, where as a country, as a group, we need to focus on. Thanks.
Let me have views of Mr. R. Subramaniam, Deputy General Manager, Quality Assurance, Bharat Petroleum Corporation Limited. And I would request him if he can talk about what sustainable materials that BPCL is focusing on. So over to Mr. R. Subramaniam.
Thanks, Prashant, and thanks to ICN for giving BPCL an opportunity to be a part of this particular panel, having an eminent panelist and a lot amount of good speakers on the part of the sustainability. And I'm representing the quality assurance part of it. Now, you'd wonder, how is the quality assurance really going to play a major role in terms of the sustainability? As you see, of India has been large amount of exporting, importing various amount of products, and where the standard of quality is plays one of the major important role. And there is large amount of promotion being done that all these labs needs to be an enable accredited as ISO IC 17025 2017. This was again, that is once tested, globally accepted. And as you see, all the laboratories, be it in a chemical sector or a manufacturing sector or a medical labs, are going for this particular accreditation. And this could have been seen quite predominantly during the 2 years of the pandemic, where in fact the government of India also stressed upon that all this COVID testing laboratories needs to be accredited as 17025. Basically, acceptance and authenticity of the test results, not only in India and also abroad. If you see, this was not, as on today, we find in India about 7,000 odd enable accredited laboratories. And before 2013, if I see, there are, because in which one of the most important parameters is the test results. And what happens is that proficiency testing plays a major important role. So what is proficiency testing? Basically, it's a tool of any participating laboratory to assess its own competency in order to perform the specific test. So prior to 2013, all these laboratories were basically participating in ASTM bodies or in a PT Australia or various other things at a cost. There are a large amount of issues that was coming across because we had no other alternative. One was basically the matrix of the product that was coming across. Second thing is that the test methods and the test validations which they were using across was not suiting into the Indian conditions. Third is a cost factor. Fourth thing is that in the process, what is happening is that many of the labs are only going about with the interlab comparisons type of things, and that products were being certified based on that. Nothing was going wrong. But the problem is that how to reach the international standard and to attain that particular amount of quality, sustainability is one of the most important factor. So that's why somewhere in 2013, BPCL was approached by NABL whether we can look into this aspect of proficiency testing. And we became the first proficiency testing provider in the year 2013. Thereupon, what we basically did is that as there are a large amount of Indian refineries across, we could get a virgin product where we could make a large amount of a proficiency testing type of a material, which was having a material matrix matching to the products which was tested in India. This really helped a large amount of the laboratories who are getting accredited as 17025, because there's one criteria that you need to participate in the proficiency testing program. So second thing was it's an Indian made, Indian conditions, Indian petroleum product. And rather than going for an imported, availability of the proficiency testing material at your doorstep, that really made a difference. And this could really see that large amount of confidence of the stakeholders and the results, which was being accepted globally also when large amount of products was being, exported across. Now, in terms going ahead, then what happened is that we also conducted one program for APLAC along with BPCL. There were about 55 countries globally and about 120 labs participated in this program. And so that we found that in India as a proficiency testing provider, we could match to any global standard. So that really brought him out a certain amount of pride into the Indian petroleum laboratories to have such a proficiency testing provider in India in the sector. So next comes what? Next is that your product, what you're giving quality has to stand. So you require a certain amount of reference material to ensure all your instruments are really calibrated. What your results are really giving is okay. Again, the challenge is that you do not have a good amount of reference material in India. So that's where we also ventured into this reference material production, got enable accredited, and again there also we became the first reference material producer in terms of the petroleum sector laboratories. Again, what happened? Accuracy of the results was most important. Calibration of the equipment is one of the most important factor. Monitoring the laboratory performance is also one of the most important, because any that production that we do, all these factors really plays a major role. And also to demonstrate a quality culture in India and the petroleum sector, it really played a greater role about it. So right now we are given to understand about 300 odd petroleum laboratories are there. And also it's all the large amount of the private sector and the lubricant sector also we find laboratories coming across where we are trying to bring in the reference material meeting the standard. But that's not the area or the end that we look into, because going ahead, as we see large amount of petrochemical sector which is coming in a greater way, as the speakers also spoke about, and with ethanol and biodiesel also coming in various amount of, so all these products require certain amount of testing, calibrations, etc. You require standard to match to that requirement. So what happened here is that we are basically having a capacity to produce all this reference material, but we are also in fact trying to tie up with various chemical institutes like IIT Dehradun, ICT Hyderabad, and various other things to join and work on the various aspect of the petroleum sector reference material production, and also take their expertise. So using this, we can come out with certain amount of reference material which is actually required for the latest instruments to give these correct results that is required in present scenario. Since it's a new field of application and have an enormous opportunity for to prepare number of materials which are suitable for Indian conditions and stable for many years, using an eco-friendly base material is that what we are looking into. In fact, as a BPCL, we have produced large amount of reference material which is comparatively more biodegradable as compared to the standards available in the international market. Going ahead, we also see an opportunity in those segments developing those materials which will benefit the petroleum industry, the chemical industry, and the petrochemical industry to a great extent to come out with a petroleum with a reference material. We are also open to work with interested industry members for producing reference material for various chemicals, petrochemicals products which are suitable to Indian testing conditions and which are not available at present. That's this one. BPCL is also being experienced in this proficiency testing and reference material for the last 10 years or more than that. Many had also done many amount of research on the material characterization for various refinery product streams and to obtain a more stable, comparatively eco-friendly reference material. BPCL has got an experience infrastructure with them and would definitely look forward in joining hands with various other chemical industries and petrochemical industries to come out with and develop reference material for Indian laboratories that would really have to sustain the various products that has been produced in India. So this is what I would just would like to share from the BPCL. Thank you.
Thank you, sir, for very elaborate things that you are doing in your what we can say quality assurance and the kind of things that you talked about, where you're trying to work with industry organization and industry, so that you can develop this moving forward. Thank you, sir. And now I reverse the order and again come back to you. And I would request
Prashantji, before you go, can I just make one statement about BPCL का जो काम इन्होंने बताया?
Please go ahead.
You see, I am so delighted to hear from Dr. Subramanian, two things he has talked about: ISO IC 17025 and reference material. You know, it's such a huge business, the reference materials. All Indian laboratories have to pay through nose, and we are all importing it. We should do it in India. And ISO IC 1705 laboratories in India are so less in number comparison to country like Mexico. More such labs, the better is the industrial growth. I just wanted to say this. And these are the points which are normally never discussed in R&D forums, but it is good you talked about it. In my opinion, each and every industry should have their own laboratories ISO IC 17025 accredited, which they are not. Each university should have their R&D labs accredited by ISO IC 17025 if we want to see that the technology from lab scale goes to the plant scale. Thank you. Sorry, Prashantji.
Thank you, sir. So thank you, Dr. Rakesh Khandal. And I again reverse the order. And here I again come back to Mr. R. Subramanian. And so what kind of, so you talked about collaborations, and so I'm asking you very specific questions on what kind of collaboration and what kind of reference material are you planning to build? Are you also looking at ethanol? Are you looking at hydrogen? Are you looking at the new, what we can say, on the petrochemical side also? So if you can talk about it, it becomes interesting for our delegates as such. Over to.
Well, now the whole nation talks about the ethanol part of it, which right now is 10%, and slowly we are moving to 20%, and that's going to be the call for some years. Definitely, we are working on that aspect of ethanol blended parameters of having the reference material. Petrochemical unit, yes, it's growing on a great level now. In fact, many of the refineries are working on it, and that's going to be the call of the day. So we are also venturing into that part of it, because as such, we are into basically core petroleum product of petrol, diesel, kerosene. And this type, being a proficiency testing provider or reference material thing, we would definitely look forward for this particular fields in particular to develop reference material and also be a proficiency testing provider to various laboratories in India in order to have sustain and also for producing food products, because any production requires a quality to be tested at each level. yes, that is two factors that right now we are looking into.
Thank you, sir. Now I come to Mr. Dr. Heathen Mehta, and my question to him would be, how do we enhance our patents? So if we can increase the number of patents, that would be very beneficial. So what are the different steps that you are taking, sir, in terms of increasing patents from India?
Yeah, so if you can see, like in last 7 years, the number of patents which were being filed by the country was around like in 2014, it was 44,000 per year, which has grown to 66,000. The huge change what you can see is that the patent grant, which was just 5,000 out of 44,000 in 2014, has reached to almost 30,000 plus last year. So that there is a huge improvement in terms of the patents being granted. And then in the past, the patents filed in India were more like 66% or more from the outside of the world. So not from the Indians straight away, from the outside countries who, or companies who used to work and develop their, sell their products into the India. In this particular year, you see it has reached to almost 54%. Indian patents. So that practically is showing the overall change in the mindset of the people and the institutes and industries, where they are more focused about coming up with the innovation and making it sustainable by sustaining in terms of filing the patents and valuing it. So lots of things are happening in industry where people are more courageous, are having much more innovation based mindset and coming up with the patents, filing their technologies and creating the IP asset, which is visible straight by the numbers only. Thanks.
Thank you, Dr. Heathen. Now, Bijal, any thoughts on patents? You are also working on a lot of them, both for your Belgium company as well as from an Indian perspective. And then my second observation, or I needed your views, is on mentoring startups for sustainable materials, how easy or difficult it is, and what should be the process to be followed for that.
Yeah, so patent, I think Dr. Heathen kind of consolidated it pretty well. That there is definitely an arena. I think enough has been said by him. The only thing I would say, and I would echo his thought, is that patenting, we don't want to do it for the sake of patenting. We want to make patents which are, useful, the ones which are industrializable, the ones which are commercializable, and where you're actually getting values out of it, and not just on the long list of, papers published that we have. And I'm being very bold here because that is normally what we look on the R&D factor a lot of times in terms of securing the area, but it never sees the light of the day. That's my thought on the patents. Coming to your question on startups, we have something in Solvay, and I'll just take a reference of that, called Solvay Ventures. And if the way I slice the word integration, if I slice the word ventures here, ventures is something taking the ability or having the ability to do something bold. So a lot of times, if you say startups or ventures, what happens is, even though they are taken as ventures, the ultimate expectation out of them is that they would be profitable the next day, and this is not the case. So I think in terms of startups or ventures, we as industry need to have the daring to fail. It's okay to dream up something. It's okay to take something on your table, fail fast, learn from it, and move ahead. So if you want to really accelerate our growth, especially in the venture capitalism, this is something that we look into. I can give some examples that a lot of our materials from went into this plane called Solar Impulse. We had it in India, I think in 2014 or 15, where it went around the world without a single drop of fuel or fuel from petrol, just on solar energy. There were a lot of inputs, a lot of R&D and material inputs which were made by Solvay in that plane, and that project is still active as a part of Solar Impulse too. And it is not only the standard venturing would be where people who have good ideas and very good technical knowledge. They come, industry sponsors them because we have better infrastructure, and we fall back on our years and years of experience in the business. Beyond that, what we are also venturing into is attracting more and more youngsters into STEM area, sponsoring their PhDs, postdocs, their higher education. We are also into, there are a group of explorers where we are always sponsoring them to travel across the northern hemisphere, take samples from various locations in terms of earth, air, water, and see where is it that we really need to focus on. Based on the analysis of that sample, we really need to focus on climate changes. So even the arena of ventures or startups is not what it used to be earlier, the standard ones. I think that has gone even beyond beyond the regular, I would say, bread and butter, and people are thinking about ways to accelerate coming into the market with more and more sustainable material. So this is the, I would say, order of the day, and we definitely support.
Vijay, just a thought is if let's do one startup mela where we get all the startups on the one side and the academia as well as industry on the other side, and then decide, okay, these are the 10 technologies that we would be working for in this particular year, and then identify the startups, okay, out of the 100, whatever the numbers, identify the startups, and accordingly, the industry starts nurturing them. What will happen is that will give a big boost to the startup. The same thing which was done in the IT or the telecom, I think the same will help the chemical and the petrochemical industry going forward, because presently there is very difficult to find startups. So if both go hand in hand, I think it's possible, because we are talking about new materials, and new materials needs a different hand holding or a different approach to the overall solution. That's thought which came after you said about the startup. So I thought of just mentioning it to all our panelists. Our next, before I come to the two stalwarts, I would request S. Sriramji, and he's also thought on mentoring startups. So if you can give your thoughts, and then I will come to Professor Dr. R.K. Khandal and G.D. Yadav. And G.D. Yadav will give his final summary points. So over to Mr. S. Sriram.
Yeah, see, to be specific about the mentoring of the startups, HPCL has been doing really a great job with respect to the startups, and we are providing an adequate platform for plenty of startups, right from our refinery segment to the marketing. So there is a separate division in our corporate office which looks after into the startups, which screens the relevant startups and they take it up. One similar segment which I want to emphasize, in any refinery, safety is of prime importance. So having said that, we have taken up a startup and we have gone ahead with virtual reality, whereby we are training the operators as well as all the maintenance as well as the project personnels with respect to virtual reality and how the safety aspect, occupational as well as your process safety aspect, has to be improved upon. Besides that, we have initiated one of the startups which is we are involved with this Biogel, which IIT Madras and the team.
We have missed you, sir.
Engaging people of the startups to be in the ethanol production sector. So basically what I want to mention over here is, from the oil and gas as a refinery segment, there is a lot of opportunities that we can provide to the startups. It can be a boost, and it is a way of bringing up the entrepreneurship in all these sectors. And it is a kind of avenue, a platform, which the government can look for to see that they can have the technologies made in-house and successful. Thank you.
Thank you, sir. Now I request Rakesh ji, if you can talk about what should be the digital approach to solve the material challenges. You have heard all the views, and how do we take this up moving forward?
Yes, yes, yes. First of all, Prashantji, let me tell you, I enjoyed listening to all the speakers. I felt like I keep listening to them and they keep talking because they were talking so high content. Just I want to talk about this time what we should do. And I go with the example. For example, I have a good experience of working with BPCL, working with HPCL, working with IOCL. We have designed products which are completely green for them. Products like coolants, which are used in cars world over. Products like brake fluids, which are used in all the automobiles and in engines. I think the petrochemical companies should decide that they should go green for that. This is one. So all of us who are sitting here should take a decision that we should go green in India. Already multinationals have started going for, they all have their plans of net zero and sustainability, but in India also it should begin. Madam Bijal ji, we have done a lot of work for Solvay, and we have designed several molecules which are green for Solvay. So I'm really proud of the fact that I'm sharing the desk with Madam. Now, for our expert from the Mehtaji from Birla, I have one suggestion. You see, Government of India has finalized 53 chemicals as key starting materials, which we are importing for manufacturing drugs, for manufacturing agrochemicals, for manufacturing paints and dyes. 53 chemicals or 54 chemicals. I think companies like Birla should really put up facilities. A simple molecule like DCDA, dicyanodiamide. Now, what is required? Prashantji, you will be surprised to note dicyanodiamide requires only lime. Only lime you require to manufacture dicyanodiamide and nitrogen. And we have plenty of both. And Birla is one of the largest producer of cement. So I think this is one thing we have to start working on it. My suggestion to ICN is that in future programs, Prashantji, you plan in such a manner, we focus on those 53 key starting materials, because we are, our trade deficit last month has been so high, we are importing chemicals from China worth $950 million. And you know how much we are exporting to them? Only $180 million. So much of trade deficit. In order to capture it, and in order to capture it in a green and sustainable manner. Madam has said about cradle to grave. Grave is never sustainable. It is the Anteshti which is sustainable. It is Panch Mahabhut concept which is sustainable. We have to bring in chemical industry all those concepts. And I would be very pleased to associate with all of you present here. DCDA, please start in Birla. It is, you require cleanse, you require nitrogen, you require lime, and that's it. And all the green materials, your petroleum oils we are supplying. You are supplying in the orchards, in apple growing areas. India Glycols have been associated with you to supply you these surfactants which are green. To green going to the green, okay? And in the last, I would say, Prashantji, let us have the program product related, technology related. For example, on hydrogen itself, what is that we are lacking? See, today's newspaper, I was reading that Ola is investing in R&D for batteries. Ola is investing in batteries. They are not manufacturing cars. They are in service, they buy cars but they are investing in batteries. You know why? because Ola is focusing maximum on two-wheelers and three-wheelers, which are only in Asia or India. And nobody is interested in doing research on batteries for two-wheelers and three-wheelers. And the question which was talked about was, will we be able to solve the problem of leakage in batteries in two-wheelers and three-wheelers? Because for four-wheelers, the Europeans will solve. And in the end, I would say the patents is a very interesting topic. You know, in India, we have unfortunately a fallacy. More the patent you have, more you will be promoted. More you will have name, I have so many patents, where they may be worthless, but still we go for patents. I give the example, Praveenji, you will be surprised to note. I give the example of Dhoot, Mr. Dhoot, who is the chairman of Videocon. He said, we did not have patents. This is a story of 12 years ago. When he acquired Thomson, Thomson had got the largest number of patents in electronics. He said, I will acquire this Thomson. Then he acquired this one more company he acquired, Daewoo. So all the patents became his. Tata acquired Tata Steel, British Steel. Tata acquired Jaguar. Imagine all the patents that they had, they become the property of Tata. Tata is doing good in automobiles today, thanks to they acquired Jaguar. So all the technologies that they got, all the patents that they had became their property. They are utilizing them for all their, new cars, which Hexa and Nexon and all that. So in the end, I would like to say, Prashantji, ICN is doing a very good service to the society, to the industry, and to policymakers. Please create platforms to bridge the gap. We have to rewrite the syllabus. We have to educate teachers what they should teach, not to start benzene and benzene derivatives. We have to teach our student what all we are importing, why we are importing, how do we make those chemicals. The syllabus has to be taught differently. Chemical engineers, mechanical engineers, we have to teach them what are the technological gaps that exist today, and we are supposed to fill them. And who can do this, highlight them? None other than you. You have been managing it. So I have been seeing the growth path that you have been following. I salute you. Please do this. Please plan out specific to product and technology, and let us catch hold of it. Why can't we capture CO2 emitted? And remember, net zero, by saying that we are getting solar power, we are getting, wind power, hydro power, that is not the way you get net zero. You get net zero by really making the chemicals recyclable. Complete, 360-degree chemical to chemical to chemical to waste to chemical. Unless you are able to have technologies to create chemicals out of the waste, you will never be sustainable. And sustainable, as I said earlier, I repeat, is only time dependent. What is most important is self-sustainable, independent of time. Anytime you like, India Glycols is self-sustainable. Always you will have cane sugar. 1,000 years later also you will have cane sugar. You will have sugar mills. You will have molasses, and you will need India Glycols. So this 360-degree thing has to be done. Thank you, Prashant ji. अगर मैंने ज़्यादा समय ले लिया तो मुझे क्षमा कर देना. मुझे बहुत आनंद आया.
I think आपका at the back end I see a lot of green, and the best way to talk about sustainability.
हम लोग प्रशांत जी अभी पर्पल हो रहे हैं. हम लोग पर्पल हो रहे हैं. We have gone to the next level. Purple is the one which is emitted carbon absorption. When you have black.
So you are the green ambassador for the chemical industry, and I see that in the background. Thank you, sir. And now I would request Professor Yadav to give his final summary. Sir, if you can give point-wise, it will be easy for all our delegates.
Yeah, thank you very much. I was listening very intently to all of them. And one of the issues which I will take one by one, for example, the patent issue. Why academias are not going into patents? One thing is to get a patent is one part of the story, and maintain it is another part of the story. And unless that patent is sold to some industry, you cannot, unless you valorize it, it is of no use. So what is required in academia is you must have this so-called technology transfer office and technology licensing office. They are required, and which is not there. And the third is where you enforce, like instead of going for litigation, because most of the time the litigation will take years and you will not be able to, get anything out of it. So what happens? Can you settle out of court and get money? This happened in the case of University of Wisconsin when they sued Apple for their A7 processor. So it can happen. So Indian academia must do patenting. So my mantra to all my colleagues was there when I was the vice chancellor, 410 patents were acquired. And I used to tell them, you must, valorize them. And the formula for success in academia, because they must collaborate with industry must be welcome. So you have the industrial professorship, adjunct professorship, vice versa. You can go to industry, spend time, sabbatical, have students in internship, and industries must welcome the students in internship. So this is the patent, publish and prosper. This is a 3P formula for academics because they want to collaborate with industry. This is the way to do it. One of the important things, was mentioned and which I have been working on is the hydrogen, green hydrogen. I can produce hydrogen in less than $1. So it is in the news. And how do I do it? I've been supported by ONGC Energy Center for last, now it is 17 years. We have developed technology, but it requires scale of operation. The pilot plants are successful, so we are going for a bigger pilot scale. And the Ministry of Petroleum has paid attention to that, and that they are also helping me. So government has to have policy for that. And one of the things which is related to this is the carbon dioxide, refineries. I can convert carbon dioxide into hydrocarbons, all sorts of hydrocarbons. We have patented that. So you can go to methane, ethane, and go higher hydrocarbons, which will be equivalent to petrol, diesel, etc. That is one part of the story. Another is carbon dioxide to methanol, dimethyl ether. So methanol itself is a very good fuel. And there are, then methanol, Niti Aayog has been talking about, methanol policy, okay? So you can have definitely methanol, and methanol can be converted into a variety of chemicals. So that is another story. Dimethyl ether, for example, it is a very good substitute for LPG and diesel. But we don't have a policy on that, which is very sad. So I spoke one of the meetings in fact, I told the government officials also, you must have a policy because you don't require additional infrastructure. Dimethyl ether is a very good fuel and it can be used, and you can produce also a variety of chemicals from that. It can also be a chemical feedstock. So this is carbon dioxide, into, then you can convert into formic acid. Formic acid is a very important chemical. It is also a storehouse of hydrogen. So you see that when you have, hydrogen coming from water and nitrogen coming from air, and you get this carbon dioxide free ammonia, then you go to a variety of this, fertilizers and whatnot, so urea and all. And government of India wants to have this by 2030, 50% of our fuel should come from this. And ammonia is a very good storehouse of hydrogen. And so it can be used in IC engines, it can have fuel cells and whatnot. So that is one part of the story. Another part of the story is what we are talking about these days. And, India Glycol, we had collaboration with them. So, we are talking about cellulose, hemicellulose, lignin, and all these things, so bio-based chemicals, because we will not have any crude oil, by 2050. So how are we going to meet our material needs and chemical needs? And so in that regard, something like 14 platform molecules were identified by Department of Energy, US Department of Energy. And see, you will find that a lot of papers have been published, but technology, it is converting that into technology is very important. So the academia should do that, and the industries must participate. Like whether it is fumaric acid, glycerol, itaconic acid, sorbitol, succinic acid, xylitol, name it, all sorts of chemicals can be produced. Very importantly, which people do not know, like lignin. We talk about lignin. But lignin, again, hydrogenation and oxidation. So we can go to diacids, aromatic acids, serine and name it. Instead of burning that lignin, you can have lignin converted into, some sort of valuable chemicals. We did some analysis. In fact, I published this paper in September 2020. We did the energy and mass balance in crude oil and biomass. Okay, just to, it was very interesting analysis. And that was based on, 97.4 million barrels of crude oil, which is processed by the refineries across the world. During that pandemic, particularly on 10th of April 2020, you know that it was price became negative. The reason being that they produce more and there are no storage. Okay, and that time that went down to 85 million barrels. So what happens when you have 1 kg of this crude oil, it gives us 32 megajoules of fuels and 0.2 kg of chemicals. But if you process 1 kg of biomass, let it be anything, it gives only 6 megajoule of fuels and but 0.8 kg of chemicals. So we did some analysis based on that 97.4 million barrels per day. So it converts into something like the refinery processes 215 barrels per second. If I convert 100% biomass, it becomes only 10 barrels per second of fuel. And if I convert 100% biomass, it becomes 320 barrels per second of chemicals, valuable chemicals. What it means? Carbon should not be burned as a fuel. And I will tell you a very good example of that. The government of India and many others have this bioethanol policy. And Dr. Khandal also mentioned about that. We will go to 10%. Yes, up to 2030, good enough, but don't waste carbon as a fuel. Ethanol can be converted into ethylene, and then you can have polyethylene, styrene, ethylene oxide, glycol, EDC, make many polymers, rubbers, polyester, PVC, name it, alpha olefins, and all those things. That is a much better proposition. And so energy should come only from solar energy, wind energy, and hydrogen. And, BP Energy had said this long time ago, maybe 2 years ago. They said that we will require something like 49,000 terawatt hours of energy in 2050. And that is the time we want to have net zero. Of that, almost 25% will be hydrogen energy. And in that hydrogen, you will have blue hydrogen and green hydrogen. Okay, so that is very interesting. And so you imagine, so hydrogen will play a very, very important role in all these manufacture of chemicals, whether you have propane diols, butane diols, 2-hydroxypropionic acid, HMF will be a platform molecule. And many of us have been working. My lab, we have done many experiments. We have got several patents also. So ultimately what it means, the industry of tomorrow will be a combination of this. And so it will be a bio-based industry. So we must have technologies developed locally. We must have hydrogen production technologies. Okay, and then you have biomass, including plastic. Government of India has a policy of plastic ban. I'm dead against it. I'm telling you why. Ban never helps any problem. Banning is a bad idea because then you have clandestine manufacture, then all sorts of illegal activities and police raiding and all. What should have been done? That should have been that collection should be the most important thing. How do you collect? If you collect same sort of polymer, for example, you have the PET bottle, okay, or polythene bag which is being used for milk and other things. Can we not have somebody who comes to the home every day in the morning, like the newspaper boy comes and collect those polythene bags? So we'll have problem of two kinds. And that is a very important source of feedstock. Believe me, this waste plastic is a very important source of feedstock. Only thing is collection. So problem, whatever pollution we did before is one set of problem. Another, what we are going to do, recycle. So I mentioned in the beginning, recycle engineering, including polymers, plastic. That is the only solution because tomorrow's world, we will have, for example, by 2025, we'll be 8 billion people. And India is certainly going to take over China. And how are we going to meet our energy needs and material needs? And Dr. Khandal was talking about 80% APIs are imported from China. And these 56 chemicals he mentioned about. why not develop these technologies in
Sir,
India?
sir,
Yeah,
I
that
will
is what I
stop
want.
here. Sir, I will stop you here because the next session is supposed to start in this same room.
No problem, no problem, no problem.
And
Because-
let me thank all my speakers for educating us with respect to new sustainable materials, both in the chemicals and the petrochemical space. Professor G.D. Yadav, many thanks, sir. Mr. S. Shriram, many thanks for participating in our conference, sir. Professor Dr. R.K. Khandal, who is a mentor for all of us, and he has been mentoring ICN. And many thanks to you, sir. Ms. Bichal Matkar, you have been a strong proponent and always helping our team. Many thanks to you, ma'am. Mr. R. Subramaniam, we were able to get, we used to get only the chemicals side. We were not getting the oil and gas and petrochemical. This time we have bridged the gap and we have broken the glass ceiling and got you. So I would request, please support us whenever we plan to do these activities, both Mr. R. Subramaniam as well as Mr. S. Shriram for their support in participating for our conference, and also Dr. Heathen Mehta. For the first time, we have been able to get somebody from the R&D team from Aditya Birla Chemicals. So I think it was a good knowledge sharing, exchanging, and also knowledge learning for all of us. I would like to thank once again all of you for making this a memorable one. And because being the sustainability being a theme, I think R&D has to play a bigger role, and it is synonymous. So if we are planning for sustainable materials, without R&D, we will not be able to do, because that's not available even globally. So if this is a new area, if we jump in with converged strategies or integrated strategies, I think we will win the race. Thank you all once again, and namaste from ICN.
Thank you.